The next presenter is Ángel Vera-Herrera. We're going to hear about the Degoras Project from San Fernando, Spain. Thank you.
Well, thanks for your kind presentation. Hello everyone, I'm Ángel Vera. I'm an engineer, a computer engineer from San Fernando Station, specialized in real-time system. And well, I'm glad to be here today to present you the project that we have been developing for a few years in our station. Well, we call it Degoras Project, a libre software and hardware for SLR stations. This name, of course, means that this project is free in terms of liberty. For example, just like other well-known projects, for example, LibreOffice, okay? Well, let us start with this quick overview. First of all, we studied some of the old existing systems, SLR systems, all over the world, and we saw several common issues. We mean only old stations, not the new ones, or the station currently under development, only the old station. Well, about the uses, we saw the use of obsolete programming language and technologies, for example, Fortran on very old operating systems. Also, we saw the use of sequential programming of very complex systems, as well as the fact that all the subsystems, including the real-time hardware, are controlled by the same sequential software. And this is a very big problem. And finally, we saw a very high degree of interdependence among the different subsystems. This in software, in computer engineering, is called a high coupling. Of course, all our San Fernando station, or oral station, also had these problems. So the maintenance and evolution of our station was very, very, very difficult some years ago. You can see here a bad scenario when in the control computer we only have one program, one sequential program working in only one process. In the same control loop, you control every subsystem sequentially. Other problem is the presence of an internal range gauge generator. In this case, an internal range gauge generator inside the same control computer produces even more coupling to the system. And this bad scenario has serious consequences. For example, the hard maintenance of the whole SLR system, the difficult integration of new hardware components and new software components, like laser, automechanical devices, algorithms, device compatibility, etc. Also, you will have, in this situation, you will have a very low computational performance that, of course, will affect the real-time systems. And well, finally, all stations usually use obsolete graphical user interfaces or very difficult to use command line interfaces with very complicated setup systems. So the system operation for non-advanced users is very, very complicated. All of this doesn't allow to the old SLR station to reach their full potential. And all these problems should be solved to bring them to achieve the maximum operational capacity of each station. Here you can see a good scenario where each subsystem is controlled by a specific process, for example, using different threads. In this case, each subsystem communicates with the control software using different interfaces implemented by specific plugins. Well, following this previous design, we start to develop the Degoras project. That is a brand new modern system designed to meet the different needs and tasks of any SLR station. But sorry, but currently it's still under development. The main fact is that this project is libre, fully libre, and this means that the project is all of it's open source, basically. The system is user-friendly for operators, engineers, and scientists, for every user, adaptable and modular. This way, the project can be adapted to any SLR station. We improve the implementation of some interesting algorithms for SLR's computing. And finally, the system is prepared for the ILRS and space debris tracking. Usually, the space debris tracking requires a more flexible system. So this project allows this. About the technology that we use to implement the system, well, we use the Qt-Fake framework. That is a very modern framework used in a lot of different projects all over the world. As main programming language, we use C++ and Python 3, among others. The hardware is based in an Intel Cyclone 5 device that is an FPGA plus a microprocessor. The hardware is our own range gauge generator. I will talk about this later. For communication between different modules, we use the 0NQ messaging library, as well as MongoDB for database systems. And well, finally, we implement a system of interface and plugins as one of the main facts, the main feature of this project. You can see here an adaptability scenario using this system of interface and plugins. This is real. This is our own scenario in San Fernando Station. In the Degoras project scope, we have defined several interfaces. And then in the San Fernando Station scope, we develop different plugins, specific plugins, to control each specific device. For example, our 2x laser, or all telescope mount, etc. Other example with this system, we integrate the well-known software Orbit-MP inside the station. Here you can see the different functionalities within the scope. In the brown box, you will see the hardware part, that is the RGG, and in the purple boxes, the software components. And well, to cover all the previous functionalities, we are developing different graphical user interface applications. And there are a lot of them, so I will show only these three, the Space Object Manager, the Station Control, and the Tracking System, because they are in a very good state of development. First, the Space Object Manager. This is a program for managing the database, the space object database, like satellite or space debris. You can search different objects, you can filter the data, update some important parameters. You can also create different sets of observations, among other interesting functionalities. Here you can see the station control. Remember that all the system is still under development, okay? And well, with this software, you can control the main aspect of the station. You can change the working mode of the station. Also, you can see here the observation planning. In this case, in a Gantt diagram, you can see the control cameras monitoring the system status, etc. And finally, this is the current state of the tracking system. Here you can see the real-time residuals data with the associated real-time histogram, the tracking polar plot with the track, and in this case with the sun. And with this software, you can also control several aspects of the track. For example, the gating, the pre-filters, or for example, the telescope offsets. Well, about the hardware part, we are developing our own range gauge generator that will be libre hardware, of course, like all the project. the gating accuracy will be enough for any SLR system, will be fully configurable and modular, and the communication is over TCP. The idea is that this system, this prototype will be encapsulated in an external standard NIM module to achieve something like this system. This is only an example of NIM module. It's important to mention that this device, or RGG, uses the CPS file internally to work, so it can operate as an independent subsystem without the need for complex integration or a dedicated computer. The first prototype of this system is working in our station from some years ago without any problem and very good result. So I think that the future is very good for this device. Here you can see a functional block diagram. Don't worry, I only want to highlight two well-differentiated parts. The green part, that is the real-time hardware, in this case working in the FPGA itself. For example, the real-time clock, the laser control with all the subsystems, for example, the backscattering module, or the range gate generator block. The other part, the purple part, is the HPS. In this case, it's the microprocessor of the Intercyclone 5 device and works under Linux. In this module, we have a high-level software that controls the whole real-time system and also offers an interface with the outside, a communication interface with the outside. Well, finalizing this presentation, you can see here the aims of the project. Of course, this is a project that are still under development, so we must continue working in the development of the Degoras. And we want to make the DRG fully compatible with kilohertz systems. In middle term, we want to include an automatic remote operation mode to the system, of course, and test the software and hardware at other stations. And this is essential because this is the idea of this project, a system that can be adapted to any SLR system. And in long term, we want to work in a multi-static mode for the RGG. And finally, we want to work in an automatic real-time global control of multiple SLR stations. And this is the final idea of the project. About this ambitious idea, well, I think that in general, an automatic libre system adaptable to any SLR station should allow to the SLR scope an standardization, an automatic operation, and a centralized control. In other words, a centralized and remote automatic control of multiple stations. And well, I believe that with this idea, the SLR community will be able to achieve a real collaborative and automatic global network of SLR stations, using not only the new well-designed SLR system. The idea is use also the old station. And well, this project can be an interesting way to achieve this goal. Of course, with the help of other entities, with the external collaboration of other entities. And well, thank you very much for your attention. I want to say thanks to the LRS for this opportunity, as well as to my teammates and the external collaboration. For example, Julian Rodriguez, thank you very much for your collaboration. And well, thanks also to the station that have shared their data and their ideas with us, for example, Hermonso. We are looking forward to collaborate with more stations. You have here my mail for anything you need related to this project or no, for anything. And well, if you have any question, I will be pleased to answer them. Thank you very much for your kind attention. Thank you.
We have about 1 minute to hear something from audience.
So thank you very much for the presentation. The software looks really nice. So I appreciate it's an open source license, but are you also developing it in the open? Like, is there a GitHub page or something where I can contribute code to it?
Can you repeat more slowly or more?
Okay, sorry. Is there something like a GitHub page where this project's being developed, where it's possible for me to contribute to the project and have a look at the software?
I don't understand, sorry. Yeah, of course.
Okay.
Yes, definitely. Okay, sorry. Well, the idea is that the project will be a collaborative project. At this moment, we don't have an open Git, for example, but in the future, in maybe 1 year, I hope this, we will publish a collaborative, for example, Git to collaborate to this software or to these systems. Is this your question? Okay, thank you very much. Sorry.
I have a little bit provocative question.
Okay.
You mentioned the language C++ version 17. So this language's specification is close to 2,000 pages. What's your look in the long-term maintenance perspective? Because people who really master it is not many.
Well, not really. It's right that C++ is a difficult language, of course. But well, the idea behind this project, one moment, please. Okay, is that yes, the Degoras scope is made in C++, of course, but the plugins. Not is necessary to use C++ for interconnect the plugins. For example, you can use Python 3 without problem. So we will avoid this difficult part of the integration that is C++. However, C++ is a very known programming language, and every computer engineer will be able to work with this project. Also, Qt5 framework is a very well-known framework. So I think that this really is not a problem to the maintenance and evolution of the software. Thank you.
Thank you very much.
Okay.
Thank you very much.